the same. Let me write it down. Let me see if I can comment on here and write it for you. Write a comment. It should be the Jack's tutor. So go in there, you'll be able to see it. Uh, yeah. So go on that there. I typed it on there. So it's the same as it's the same name as the name on TikTok and kind of like the same as the one on Instagram, but it doesn't have the underscore on it. So if you go on YouTube and type that, you'll see it. It'll go directly to it. And then I think on the page on my profile, you will have a direct link to go on YouTube to see what's going on. And that's the easiest way to do it, I would say. Just go on the profile and then type the link. Jessica, what's up? All right, so let I think we can start now. Let me share my screen. Uh and I have some stuff that we want to start today. Some of them are simple. And if you're on YouTube and you're able to see my screen, let me know as well. So let's see. All right, cool. I think this is it. All right, so let's start with some simple stuff that you guys, simple questions that you guys have. And as people are coming in, we're gonna answer a lot more of them. And one of the first questions that we had since probably last Tuesday. So someone was asking about one step and two step equations. One step. Let me have two page open just in case that this thing uh just in case this thing all right, so just in case one page closed. So one step and two steps equation. They want two steps equations. And do you guys know what those are? Let me see if we can who can tell me what those are in like a nutshell, if you know, like, hey, like in a few words, what do you think they are? So one steps and two steps equations. What do you think they are in a few words? So basically, as the name entails, is equation that you can solve in one step, or the ones that you can solve in two steps, and that's what the name, that's where the name is coming from. Hey, I can solve this in one step. That's a one-step equation. I can solve the. I need two steps to solve this. It's a two-step equation. I'm trying to find the best way to. Okay, so if you want to see the screen, you gotta go on YouTube to be able to see it. Let me move this notebook right here. So let's say that you have an equation like this. Let me see if you guys are able to see the screen on YouTube. Yes, I know some of you guys are on YouTube. Okay, so let's say that you have an equation like that, like this. Hey, what's up, Danielle? So let's say you have x plus 12 is equal to 4. So let's say you want to solve for x or whatever the variable is you wanted to solve for in a one-step equation. So what that really says is, hey, you only need to do one step to solve for that variable x. You only need to do one thing to solve for it. And usually it's either add or multiply or divide, but it's one step. After you do that one step, you should have x by itself. And that's what the one step equation say. Hey, after you have that one step, you've done that one step, x will be isolated by itself, and then you'll be able to solve for it. So in this case, how would you solve for this? So who can tell me how you would solve for this one, the first one? X plus 12 is equal to 4. How would you solve for it? Come on, guys, on YouTube. I know you see the screen. So how would you solve for this? X plus 12 is equal to 4. What would you do to solve for x? Simple and easy. X is equal to you. So what would you do is yes, take away 12 from both sides. Yeah, that's right. Subtract 12 from both sides. That's right, Daniela. And you guys are answering here. You should go on YouTube so you can see this. Minus 12. Yeah. And then what you would have is, that 12 is gone. X is equal to negative 12 plus 4. And that would mean that x is equal to negative 12 plus not 8, 4. Negative 12 plus 4, that means x is equal to what? What's negative 12 plus 4 is? What's the answer, guys? Negative 12 plus 4 is negative 8. Yeah. Okay. So that's a one-step equation. The other way that you can see this, now we had to either add or subtract. The other way that you can find a one-step equation, yes, that's right, negative 8. That's right. Yeah, negative 8. That's right. Daniela, that's right. Divide by I don't think you divide by 8. I think you meant negative 8. So the other way that you can solve for this is the other, one step equation that you can encounter is one where you have to either multiply or divide to get x by itself, because that's the whole point. Okay, I want to get x by itself. Either I add or subtract, or I multiply and divide. Yeah, I imagine that's what you meant, Daniela. All right, cool. So let's do the second case. Let's find the second case. So the second case that you can find is, let's say that I have a variable y divided by 3 is equal to 8. So what would you do in this case? Even or odd functions. Okay. Yeah, we can find that. Okay, I'll show you how to do that. Even and odd function. Mike. We can do that in a little bit. Okay, so now how do you with this one, y divided by 3 is equal to 8. It's a one-step equation. That means after one step, y will be by itself, and then all you have to do is, whatever is left to do. If you multiply through to get y by itself, and all you have to do, just like this one, is, okay, all I have left to do is this operation. And that's what this says too. This is a one-step equation. After I multiply through by the number to get y by itself, all I have to do is that operation that's going to be on the right side. So what do I need to do here to get y by itself? Someone who talk about one-step equation. What do I need to do to get y by itself? So, come on, guys. So how do I solve for y in this case? I multiply both sides by 8. I'm not sure if I'm coming a little bit late for y'all. Multiply both sides of the equation by 8. So let me use a different color so you can see it. Multiply this guy by 8. I mean by 3, actually, not 8. Multiply this guy by 3 as well. So this 3 is gone. So I have y by itself, which is, that means the one-step equation. All I have to do is one step, and then y will be by itself. What's 3 times 4 times 8? 24. And that's how you would solve for this one. Now, this is different from when you have a two-step equation. So does that make sense? Does this make sense, guys? I know this is like very simple stuff, but someone asked a question about one-step and two-step equation. So does this make sense? Yes, no, maybe? Yes, I do private tutoring for ACT and SAT. Go on my website, you'll see it. You'll see all the information. So everything and that I'm referring to now, the YouTube channel, the website, they should all be in my profile. So once you click on the profile, it should pop up the jackstutor.com. Oh, yes. So you can just go in there, and then you'll see other information. All right. So let's do a two-step equation. So let's say I'm doing a two-step equation. I have an example here: 3x minus 4 is equal to 6. So what that really means is saying, okay, I need to do two steps before I get x by itself. What's the first step here in this case? What's the first step I need to do? I'm not seeing the comments here on YouTube. So what's the first step I need to do here to get x by itself? To get x by itself, the first step I need to do is add -6 to both sides, right? -6 and -6. So this on this side, what do I do? That 6 is gone. I'm going to have a 0 here. No, I'm trying to get x by itself. Why am I adding -6? That would be more than two steps. Okay. So the first thing I need to do is add 4 to both sides. Add 4 to both sides. So what was that? -4 is equal to 6. Let's add 4 to both sides. +4 +4. So on this side, 6 plus 4 is 10, And on that side, a 4 is gone. 3x is equal to 10, right? 3x is equal to 10. Now, what do I need to do to solve for x? I divide both sides by x. Divide both sides by 3, actually, by 3. And you get x is equal to 10 over 3. This is basic stuff. This is easy stuff that you guys can solve. The other way that you can see this is the first way. What I needed to do is add and then divide. You can, add or subtract and then divide. You can have something on a two-step equation of this way. Let's say you have t is divided by 3 is equal to, minus 1 is equal to 8. Minus 1 is equal to 8. Let's say that's what you had. So let's say this is okay. This is what I have, and I want to solve for t. So the first step to get t by itself would be t divided by 3, and then I add 1 to both sides. I add 1 to both sides of the equation. Add 1 to here. Add 1 to here. T divided by 3 is equal to 8 plus 1 is 9. And all I have to do now is multiply both sides by 3. That's step 1. This is step 1. I add 1 to both sides. And step 2 would be multiply both sides by 3. So 3 times t divided by 3. 3 multiplied by t divided by 3 is equal to 9. And that 3 is gone. Multiplied by 3. That means t is equal to 9 times 3, which is 27. This is not, I know I went over this a little bit fast, but I don't see any questions. I'm assuming that you guys understand what this is. This is very simple stuff. So now I have some stuff that I'm going to see it. Like I said, if I say it here and you show enough interest for it, I'll do it. If you don't, I won't do it. So I had one question about how to find the partial derivatives of a function. There's another question that asked about derivatives of inverse function. There's a third question that has about slope of a equation of a tangent line. Okay, if I see any interest for any of those questions, I'll do them. If I don't, that means we're gonna move on to something else. Okay, I saw a question about even and odd function. I think we can do that right quick. Let me see who asked that question. It was Mike Land. Are you still here? Okay, so let's do even and odd function algebraically. What does that mean? An odd function. So even function means that if normally this is what you would see in a book. That probably doesn't make sense to you. So let's say if I have f of negative x is equal to so you're gonna have either f of negative x is equal to negative f of x, or f of negative x is equal to f of x. So one of those means even function. One of those it means yes, I do one-on-one tutoring. Yes, I do one-on-one tutoring sessions. Normally people would go on the site and they would schedule one. So if that's what you're asking, that's normally how it works. I don't know how I would do it on Instagram. But yeah. So this is how they normally write it. So what that really means is if I pass on a negative value inside of the function, if I pass on negative x, I'm gonna get negative f of x. If I evaluate for even function, f of negative x is equal to the same thing as f of x. For odd function, f of negative x is equal to negative f of x. Let me give you some examples so that makes sense for you. So let's say we have f of x is equal to x squared. Let's do the most simple stuff. So what is f of 2? F of x is equal to x squared. What is f of 2? F of 2 would be 2 squared. But what is f of negative 2, which is 4? What is f of negative 2? F of negative 2 is negative 2 squared, which is the same thing as 4. So that means, what does that say about f of x? F of x is an even function. Now I plug in x. What to do after? Okay, so I know I have to plug in x, and I don't know what to do after. So let's say you wanted to prove that. So you wanted to prove that it's an even function. Okay, Mike. So in this case, f of x and f of negative 2 is equal to f of 2. And that works for any value of x. You can try them if you want to. So is equal to f of 2. That means this is an even function. So let's say that you had the function here. So let's say you wanted to prove that this is an even function. So let's say you had f of x is equal to x squared, and you wanted to prove that this is an even function. So to prove that this is an even function, f of negative x should be equal to f of x, right? So for any x values, f of negative x should be equal to f of x. Now, what's f of negative x? That would be negative x squared. What is f of x? X squared, right? Right? So what is negative x squared? I can move the negative 1 out. That would be negative 1 squared times x squared. And does that equal to x squared, right? So negative 1 squared is what? 1 multiplied by x squared. Does that equal to x squared? X squared is equal to x squared. So that means it's an even function. So it can be even, odd, or neither. So some functions are not even, not odd functions. So this is an even function. Now, if you take the function f of x is equal to, you can try that yourself. F of x is equal to x to the third. This is not an even function. But when you evaluate it, you're going to see it pop. It's an odd function. Yes. Okay. I hope that makes sense, Mike. So what you can do, if you have numbers, you plug in those numbers. If you don't have numbers, you can prove it yourself, So I prove it for you here. So what it is, I started with, okay, does f of negative x, does that equal to f of x? So I evaluate f of negative x. So that means, because I define f of x equal to x squared, so that means f of negative x would be negative x squared. Now, what does that give you? You factor out the negative 1, and then you see that f of negative x and f of x is the same. So that's how I would prove that. That's how I would say, hey, f of negative x and f of x is the same. All right, cool. So you guys got to let me know which one of these you want to see first. Equation of a tangent line, partial derivatives. That's the one that's talk about multivariate calculus. And the third one is derivative of arc sine or arc cosine, inverse trig functions. So which one of those you want to see first? Those are like calculus and probably some advanced algebra stuff. So if you want to see any of them first, let me know. If not, I'll just pick one and just go with it. The second one, which one is that? Which one is that? Is that equation of a tangent line? Which one did you want to see first? Weenie. Because you guys all asked those questions. So okay, the tangent. Okay, all right, cool. So let's do equation of a tangent line. So let's say you have a function. So let me show you really what that is. So let's say in visuals, what they would want. So let's say they have a function. Let's say I have a function here, and I have a point here, and I draw a line that's tangent to the function. So that means it's gonna touch it in one point only. It's not even gonna it's just going to touch it at that one point. It's not going to cut it. It's just going to touch it at that one point and then go about its way. So the line will go up and down like this, but it touched the function this way. So what they want really is the equation of this line. This is the equation that they want. So now let's see how we can find the equation. So the equation of the line, the way to normally write it is, so y, and they normally write it in point slope form. Y minus y1 is equal to m, which is the slope, x minus x1. And you can, after you find this equation, you can put it in slope intercept form. So it's not that hard to put in slope intercept form. So let's say that we need the function, and we're gonna find, so all we need is the function, and then the point that the point that we need the equation of the line at whatever point we need the equation line, and then we'll find the equation on the line. So normally when they give you the problem, they give you a function. Let me go in blue and write this function for you. So let's say that we have a function, for example, and we have a function of x squared minus 3. So f of x is equal to x squared minus 3. So let's say that was this function. And then we want to find the equation of the line of this function, and at the point, at 1. So what does that mean at 1? That means that x is equal to 1. So now at 1 means that x is equal to 1. The value of x is equal to 1. So whatever x is equal to 1. So let's say this is 1, and we wanted the equation of the line at this point, 1. So let's say this is 1, for example. X is equal to 1. Y would be equal to what? -2. This is not a good representation of it. But so at that point, x is equal to 1. Let me erase the graph. See, because you don't really need the graph. I was trying to explain this to you so you know what the equation of the tangent line looks like. So we need the equation of the tangent line at that point, x is equal to 1. So the first thing that you do is, okay, let me see what I have. I know the point, no. The point x is equal to 1, I know that, and that's what we call x1. X is a variable, x. Y is another variable, y. Now what I don't have is y1, and I don't also have is, I don't have the slope m. So y1, if I have the equation at the point x is equal to 1, x1 is equal to 1, to find y1, all I have to do is feed that back into the equation, put it back in the equation. So what I do is say, what's f of 1? X squared minus 3, evaluate at x is equal to 1. What is that? At x is equal to 1, 1 squared minus 3 is equal to 1 minus 3, which is -2. Now, so, okay, I have this y will stay the same because it's it's the dependent variable. The x will stay the same because it's the independent variable. The x1, I know it's 1. The y1, I know it's -2. All I'm missing, what am I missing, Mike? What am I missing? What's the only thing I need to calculate? Come on. What's the only thing I need to calculate to find the equation of the tangent line? What's the only thing I need to calculate to find the one? No, we have the y is already, no, we have the y is gonna be the same. Why? Because when you write an equation, remember, equation is y is equal to mx plus b. These things, they don't normally put anything for them. They just, like the equation y is equal to 3x minus 5. So what we don't have here is we have the y, we have the x1. X1 is equal to 1. We have x is going to stay the way it is. Y is going to stay the way it is. We have the y1 because what we did, we plug in the x1 inside of this function. We found y1, which is f of x1. That's the same thing as y1. So now all we need, no, not the b part. All we need is the slope. We don't have the slope. That's what we don't have. So most of the work is is finding the slope. That's all it is. Let me start that over again so you can really understand what I'm saying. So let's say they give us a function. They give us a function. Let's say f of x is equal to x to the third plus 3x squared minus 5. Okay. And they want the equation of the line at the point x is equal to 1. Let's say x is equal to 1. So they want find the equation of the line, of the tangent line, equation of the tangent line, not the line, the tangent line at x is equal to 1. So the equation of the tangent line, and this is a formula that you need to remember. What it is, the way you write it is y minus y1 is equal to m, which is the slope, x minus x1. So which is the same thing as the point slope form that you normally know. So what does that mean is all we need is the equation of the line is going to follow this. All we need is find each one of those. The x1 is the point that they give us, the 1, right? We got that. The x is going to stay the variable, so it's not even something that we're going to look for. We're just going to leave it as x. Okay, we have that one. This one we don't have. The y is going to stay the same way. We have that. But you got to understand almost everything that you have. The y1, you don't have it. It's the easiest thing to calculate. The way you calculate the y1, you feed that into this equation. Okay? You calculate the y1, you feed that into this equation. So what you do is put the y1 inside of this equation. So what I need is 1. So 1 to the third. So that would give me, I'm going to replace x by 1. That was 1 to the third plus 3 times 1 minus 5. 1 to the third is 1. 3 times 1 is 3 minus 5 is, that gives you 4 minus 5, which is -1. So that y1 is -1. So me, if I'm solving for this, the first thing I would do, because the slope is a little bit harder to calculate, first thing I would do, they will give you the x1, because that's the only way they say, hey, that's the only way you will know. That's the only way you will know what to calculate, what equation of, which equation of the tangent line they're asking about. So they will say, hey, here's the function. We want the equation of the line at that specific point. So now the point will be the x1. To find a y1, you replace the x1 inside of the function. You find a y1. And then all you have to do now is find a m, the slope of the line. So how do you find the slope of the line? So the first thing that you do, you take the derivative of this function, and then you plug in, and then you find the slope. So I'll show you how to do that. So the slope will be the derivative at the point that the derivative of the function evaluate at the point that they're asking about. That point they're asking you about is going to determine everything. First, you use it to find a y1. Second, you use it to find a m, which is the slope. So first, you use it to find a y value. Second, you use it to find a slope. To find a y value, you just plug it inside of this equation, and inside the equation to find a y value. And to find a y value, I just plug it inside of this equation. To find a slope, I plug it inside of the derivative of the equation. Now it's not really confusing. So let me show you. So we found y1. We need the slope. So let's find the derivative of the function that we had. Let's stick to the function that we had. Let me go with the function that we had. F of x is equal to x squared minus 3, because it's a simpler example. I think you guys will understand it better. So we want the equation of the line, equation of tangent line at x1 is equal to 1. Okay, so what's the formula for equation of the tangent line? Okay, glad you got it, man. Glad you got it. So what's the formula for equation of the tangent line? Y minus y1 is equal to mx minus x1. Okay, x1, they already give it to us, which is 1. X is going to stay the same. Y going to stay the same. Y1, how do we find y1? You plug it in there. You plug it inside of this equation. So 1 squared minus 3 is negative 2. So y1 is negative 2. To find y1, I just plug that one that they give us, plug it inside of this equation. Let me do the arrow in a different color so you understand where it's coming from. I plug the 1 inside of this equation, and that gives me the y1. So all I have left to find is the slope. Now, how do we find the slope? I plug that one. The one that they give you is very, very important. They're always going to give you that if they're asking you for the equation of tangent line, unless the question is phrased in a different way. So that one, this is the same one that you use to find the slope. So how do we find the slope? We first calculate the first derivative, the derivative of this function. So derivative of f of x, x squared minus 3. So we find the derivative of x squared. F of x is equal to x squared minus 3. What is f prime of x? Which is what? Easy way to do this. You bring this up front and you take 1 out of it. So 2, you bring the 2 up front, 2x, 2 minus 1 is 1. So the derivative of 2x, and then the 3 doesn't have any x next to it. It's a constant. So it stays, it turns into 0. So 2x, f prime of x is equal to 2x. So what do I need to do to find the slope? The slope, plug in that 1 inside of this 2x. That's what's going to give me the m. So what's the slope? M is equal to 2 multiplied by the 1, the point that they ask us to evaluate the tangent line as. That one. So m is equal to what? 2 times 1 is 2. So now I have everything I need. So what's the formula? Y minus y1 is equal to mx minus x1. Okay. Y. What was y1? What did I get for y1? When I plug in the 1 inside of the first equation, I get y1 is equal to negative 2, right? So y minus negative 2, let me put that in this way, is equal to m, which is 2, x minus x1, which is 1. Now we're done. Technically, we're done. So all I have to do is y minus negative 2 minus 2 is plus 2. 2 times x is 2x. 2 times negative 1 is negative 2, right? And I'm trying to write it as y is equal to mx plus b. So all I have to do is take 2 away from this side, subtract 2 from both sides. Y is equal to 2x minus 4. And that's the equation of the tangent line at that specific point. And there's a bunch of tangent line, an infinite number of tangent line. But at that specific point, this is the equation of the tangent line. So 2 things you're always going to need. They're going to give you the x1. What you're going to need is the y1 and then the slope. The y1, because you have x1, you plug it inside the equation, you get it. And then the slope, because you have x1, you plug it inside the derivative of the equation and you get it, the derivative of the equation. So, questions? I probably went too fast. Did I? Question, guys? Yes, no, maybe? All right, cool. So, what else do you guys like to see? I feel like I lost some of y'all. And now, okay, I'm glad that you got it, Weenie. All right, what else that you guys want to see? So I have how do you solve a function? Okay. Be more specific. How do you solve a function? So are you trying to solve an equation? Are you trying to solve for a variable inside a function? So a little bit more specific. Okay. These are the other stuff that I have here. I prepared for y'all. So one of them is, I know you guys were asking about multivariate calculus, so partial derivatives inside one. Okay. Variable in a function. Okay, let me No problem, Kaylee. Okay, so I have partial derivatives, which is multivariate calculus that you guys were asking about. And then I have derivatives of inverse function, inverse trig functions. Yeah, I have partial derivatives and derivatives of inverse trig functions. Derivatives of inverse trig functions. So if you guys want to see any of those, I'll do them because I prepare them for y'all. Anything else that you guys want to see? Let me see. Instagram. I feel like derivatives. Okay. All right, cool. Someone say derivatives. All right. So Chris is say derivatives. All right, so let's see if we can find derivatives. But do you want derivatives of inverse trig functions, or are you doing derivatives? Yes, I am. Okay, I'll do derivatives for you, Chrissy. Okay, so let's do some maybe simple ones. Okay, so let's say we have let's do the most basic one. So one of the ones that you probably see derivatives of functions that are of quadratic functions. So what you have is, let's say you have f of x, and if you have any other questions, please ask them, as equal to x squared. So how do we find the derivative of this function? What is the derivative of f with respect to x? So df dx. So how do we find the derivative of this function? So what I normally, you can try to memorize the formula. So what I normally tell people is just bring that 2 down, whatever was here, bring it down, and then take 1 away from that exponent. So that 2 is I'm gonna bring it up front, 2, x, and I'm gonna take 1 away from that exponent. 2 minus 1, which is, that derivative is 2. 2 minus 1 is 1. 2x to the first power, which is 2x. So that's derivatives of, functions like this. So let's say I have, and let's say I have a function like x cubed negative 4x to the 5th plus x cubed plus 5, for example. So if I wanted the derivative of this function, so how do I find the derivative of f of x? If f of x is equal to this, how do I find the derivative of x with respect to x? So how do we find this? So the first thing that we say, okay, let's do it. It's similar to what we just had. So I'm gonna do this multiple times, the same thing that I did earlier. So I'm gonna bring the 5 up front, and I'm going to take away 1 from the exponents. I'm going to bring the 3 up front, and I'm going to take away 1 from the exponent. This doesn't have any x in front of it. That means it's going to be 0. It's going to go away, because the derivative is always with respect to x. So everything that doesn't have x in front of it is considered to be a constant. So it doesn't have a variable next to it. So I'm going to bring the 5 up front, 5. And then that's going to be multiplied by negative 4. And then that x, I'm going to take away 1 from the exponent. 5 minus 1. Let's leave that there. 5 minus 1. I'm going to leave that this way for now. And the same thing I'm going to do for the second one. 3. I'm going to bring the 3 up front. And this is the first part. Let me write this and let me circle this so you understand. This is the first part. So that's the derivative of this part right here. So this is this one. So let's do a different color, maybe a green, to show you what the derivative of this part looks like. Derivative of this part, I'm bringing the 3 up front, and then I take away 1 from the exponent. So 3x to the 3 minus 1, right? And then the 5, I told you it's gone. It's a constant, so it's gone. So now, how do I find the derivatives of the red one? Let's say the red one is what? So 5 times negative 4 is negative 20. X to the 5 minus 1 is 4, right? And then the green one is plus 3x to the what? 3 minus 1 is 2, x squared. And that's how you would find the derivative of this. And that's it. That's how you would find derivatives of functions like looks like that. So no more complicated stuff in terms of derivatives. You can go into, like I wanted to talk about, I don't the derivatives of arc sine, stuff like that, and partial derivatives, which is when you have uh, multivariate calculus. So if you have multiple variables, you have an x and a y. You want to take the derivative with respect to x or with respect to y. So we can talk about those two if you want to. If anyone want to ask about it. So how do you do the one that looks like absolute value of 5? Billa, what are you referring to? Okay, so Christy, what's the question? I need help with determine if lines are parallel. If they're parallel, Christy, they have the same slope. That's about it. And if they're perpendicular, their slope are the reciprocal of each other and with a different sign. So if for perpendicular, so if one of them has a slope 2, the other one will have a slope of -1/2. So I'm going to take the reciprocal of this. So this is 2/1, so it's 1/2. And then the other slope for the perpendicular line will be -1/2. But if they're parallel, if this slope is 4, that slope is 4. If this slope is -5, that slope is -5. So that's how you find out if they're parallel. They'll have the same slope. I'm getting confused. I'll say I could break down. Okay, so absolute value. So here's what I normally do. So I'm gonna give you. So let's say I have a number here. The absolute value of a number. This is one thing that you understand. It needs to always. It's always going to be positive. Now, what's absolute value of 5? 5, right? What's absolute value of -2? What's the absolute value of -2? Bella, I want you to answer. And then we're gonna go into when you have x in it, what you should do. Okay, so if you give 3 pairs of line, you want to see which one are parallel, you have to okay, Bella, it's 2. So because it needs to be positive. It needs to always be positive. So -100, what's the absolute value of that? That's 100. It needs to be positive. So that absolute value means take, normally they say the distance from that to 0 to the origin, but it's just take the positive of it. So if it was already 100, the absolute value remained 100. But if it had a negative in it, it's just going to be positive. So it's a constant positive. No, not quite. I'll show you. So it's always positive. 1,000. The absolute value of -1,000 is 1,000. Now, so how do we find the absolute value of something that you don't know if it's positive or negative? So let's say I have x. Absolute value of x is equal to 3, right? So x could be positive, it could be negative. So if x is already positive, I'm gonna take the negative of it. So I'm gonna leave it the way it is. So if x is already positive, I'm gonna leave it the way it is. So it's gonna be, so I'm gonna solve the equation. If x is positive, I'm gonna solve the equation x is equal to 3. And then that would be x is equal to 3. But if x is negative, and then this is a simpler case, I'm going to take the negative of that. So if x was negative already, I'm going to take the negative of that, and then that's how I'm going to find the absolute value. So this is what we did here. So So when we wanted the absolute value of 5 was already positive. I take the 5 the way it is. When we want the absolute value of negative 100 is negative. So I take the negative of that, and that's what's going to give you the result. So negative times a negative will give you a positive. So that gives me 100. So bottom line is, if you have anything that you're taking the absolute value of, that thing is going to be positive. Now, if you solve it in an equation, you're going to take two cases: when whatever is inside the absolute value is positive, or when whatever is inside the absolute value is negative. Am I making sense? So let's say normally this is how I would do it. So like, let's say I have x minus 3, absolute value of x minus 3 is equal to 5. So if this whole thing is positive, if this thing inside of this absolute value is positive, so all I'm solving for is x minus 3 is equal to 5. So that means x is equal to 8, actually. 8. But if this thing, if it's not positive, it's negative. What can I use for negative? Black. If it's negative, if this whole thing inside of the parenthesis is negative, so I'm going to have to put a negative sign in front of it. And then that's what I'm going to solve for 5. So what you need to do, multiply both sides by -1. If it's negative, we'll multiply both sides by -1. So I have x minus 3 is equal to -5. And x is equal to what? -2. Now, -2, one value is -2, one value is 8. Let's check them. Let's check them, right? So -2. So what I had is absolute value of x minus 3 is equal to 5. So I say the answers are either -2 or 8. So the absolute value of x minus 3 is equal to 5. Is that what we had? X minus 3 is equal to 5. That's what we had. Oops. Right? So now one answer give me -2. I plug in the -2 here. So absolute value of -2 minus 3 is equal to 5. Is that the case? Yes. Yes. What's negative? So absolute value of -5, which is 5. You see how this is inside of the parentheses is negative? Because that's the second case we considered. That's where we got the 2 from. Whatever was inside of the parentheses is negative. And that's how we got the -2 answer. Now, if we plug in the 8, whatever is inside of parentheses is going to be positive. So 8 minus 3 is positive 5. So if you're solving for something that's, solving for an equation or an equality, you consider two cases. Whenever whatever is inside of the equation is positive, whenever it's negative. Now, if you're solving for, if you're not solving for equation and they give you numbers, so let's say they ask you for absolute value of -5, it's 5. Absolute value of 5, it's 5. Absolute value of -15, it's 15. So you just take whatever the positive is. But if you have a variable, you consider two cases, so you understand that whatever way it comes out, when I put it inside of parentheses, I'm going to have a positive. Thank you for breaking it down for me. I really appreciate it. No problem, Bill. I hope you understand it. So yeah, I hope you understand. So if they give you numbers, just take the positive sign. Take away any negatives and just give you the positive sign. But if they give you variables, break it down into two cases. Whenever what's inside of parentheses is positive, whenever what's inside of the absolute value is negative. Thank you for all the work. Thank you. I appreciate you. All right, cool. So, how do I find the slope of 2 points? So, okay. So let's say that you had, I know you were talking about the lines to see if they're parallel. So let's say that you had, 0.25 and another 0.71, for example. Let me put -1 so we make it a little bit complicated. Yes, go on the site. You'll see the information for tutoring, for private tutoring. Kiana. Yes, go on this. Go on. Click on the link to my page, and you'll see information for private tutoring. Or you could Google the name, the Jax Tutor. But if you go on my profile, you'll see the link to the website. It should take you to my website, and then you just book a session for private tutoring. Okay, so how do you find a slope between these 2 points? So it's easy. So the formula for that is y, let's say y2 or y2 minus y1. Let's say y, let's call this point A, let's call this point B. So let's say yb minus ya xb minus XA. So it's the same thing that they normally say rise over run. So it's the difference in Y values divided by the difference in X value. Rise over run. So distance in Y values divided by the distance in X value. So what do you do? So you take the Y coordinate. Now, the only thing with this is you have to stay consistent. If you start with B, this needs to be B, and then the second one needs to be A. If you change it, you're going to find a different slope. Okay, so now YB is -1 minus Y1, 5, XB, 7, minus XA, so 2, minus 2. Okay, let me go over this again. YB minus YA, this is Y, the Y coordinate of the point B, -1, minus the Y coordinate of the point A. So rise, the distance in Y value, minus 5, right? Divided by the distance in X value. So the X coordinate of the point B, 7, minus the X coordinate of the point A is 2. So what you have, -6 over 7 minus 2 is 5. And that's the slope. That's the slope. Notice you could have started with A. It would still give you the same slope. So let's do, all you have to do is just be consistent. You could have say X, YA minus YB divided by XA minus XB. So you see how I stayed consistent. I started with A at the bottom, I minus B here. So the only thing I need to do is be consistent. So what's the Y coordinate of the point A? 5 minus the Y coordinate of the point B, 5 minus the Y coordinate of the point B minus -1. What's the X coordinate of the point A? 2 minus the X coordinate of the point B minus 7. So what does that give us? 5 minus -1, that's 5 plus 1, which is 6. 2 minus 7, which is -5. So -5 over 6, the same thing that I found here, -6 over 5, actually. So yeah, that's how you do it. If you have 2 points, you find the slope that way. Now, if you had three different points, 3 pairs of points, you find the slope of each one, I would say. I think that's what you were asking. And then after that, you just see which ones have the same slope. And then those lines that have the same slope, that means they're parallel. Kaylee, I think Kyle, I think that was the name. Okay. Kian. All right. I know I messed up your name. Yes. So that's a pair of points. So that's the slope. So you can't find a slope with 1 point. You need a pair. You need 2 of them. So now you find the slope between these 2. Now find the slope between the other 2 pairs that you have. And then if they have the same slope, that means they're parallel. Does that make sense? K Style. I know I'm messing up your name. Everybody's name. All right, cool. Any other questions, guys? I know the screen wasn't looking right. Okay, you want to do some limits. Okay. So, how do you do? If an equation is linear, okay, so that means it makes a line. So if it's a linear equation, it makes a line. So that means so you know, if you have like this, let's say you have y is equal to, normally the you won't have a second, you will have x to the first power. So y x to the first power, and then it could be plus or minus whatever, 6, 8, 13. That's a linear equation. So that's the one that normally is y is equal to mx plus b. So that's the form of a linear, linear equation. So if you have x squared, that then you start having quadratic equation. That's not linear because it doesn't make a line. This makes a line. If you graph this, y is equal to 3x plus 6, it's gonna make a line. Now it's gonna make a line. But if you graph anything that doesn't have that, he said Noah. He said I ignore you. What's your question, my man? Let me see if I see your question. Okay, solving equation by graphing and elimination. Okay, so let me see. So let's say you have two equations you wanted to solve. Linear equation. Okay, so let's say you have two equations you wanted to solve. So let's say you have an equation right here. And I'll graph something here. So let's say you had a line, this line right here, and then you had another line. Let me use a different color for this line. Let's say you had a line this way, and you had another line that way. Now, the solution of these two equations is this point. And that's it. The solution of these two equations is this point right here. So if you are able to graph the line, you can visually see what the solution is. So if you're able to graph the line, you can visually see what the solution is. So let me give you an example. So let's say we have, and then I hope I don't mess this up. So for that to happen, I gotta make sure I graph this properly. So let's take this equation right here. 0, 1, 2, 3. No, actually, no. Let me take this line, for example. And I don't know where this is gonna go. I'm just trying to make a line that looks I'm trying to make a line that looks that I have the slope for it and I also have the points for it. So let's say I have this line right here, right? Let's say it passes through here, through here. So these ones are each one 1, 2, 3. It passes to the point x is equal to 3, y is equal to 0. It passes through that point. Let's say I had another line. Let's say I had another line that passes through this point right here. So let's say I had another line this way. That passes, that goes, here, here, and here. These lines actually look like they're perpendicular. So now these two lines, they intersect at this point. So the place where they intersect, if you can graph the lines, the place where they intersect is the solution of the equation of the system of equation that you have. So there's the equation for this line, y is equal to, mx plus b. And then there's another equation for this line, y prime is equal to m prime x plus b. So these two equations, they intersect, these two lines intersect right here. So that means that's the equation. Oh, and do an example making a system of equations and solving them word problem if possible. Okay, um so let's I don't okay, I'm gonna give you an example of solving a system of equation. The easiest way to do them, let's say you had, and I'm not saying these are equations of these lines. So let's say you have x plus 3 is x plus 3y is equal to let's see, 1, -1, -2, right? X plus 3y is equal to -2. And then I have 2x minus y is equal to, let's see, 3. Okay. So now how do I solve the system of equation? There are many ways to solve for it. And like you were saying, by, addition or elimination, you can solve for it that way. So the easiest way I know to solve for these equations. So by the way, when you want to solve, if you have a system of equation this way and you want to solve it by graphing, so what you would do here, the first thing you would solve for y, and then you'll have y is equal to mx plus b. Now you can graph that, and you solve for y again, you have y is equal to mx plus b. You can graph that as well, and then wherever they meet, that's where the solution is to the equation. Now, the other way to solve for this is, if you don't have to go through all of this, unless they ask you, is the easiest way is, by eliminating one variable and solve for the other one. So, and we've done this before here, so I'll show you how to do it. The first thing I would do is, okay, what's easy for me to eliminate here in this case? In this case, I have, so what I want is, if I'm eliminating y, what I want is, if I have 3y on top, I need -3y at the bottom. The first equation has 3y, the second equation has -3y. So if I'm eliminating x, if the first equation has -2x, the second equation have 2x. I can eliminate whichever one I want. So let's start with y. So let's multiply this equation by 3. What I mean by this, the second equation by 3, the whole equation is going to be multiplied by 3. So everything, including the equal to 3, that 3 as well is going to be multiplied by 3. So what I do is, the first equation is going to stay the same way it is. I'm not going to write it. So let's rewrite the second equation. So what's going to be 3 times 2x, that gives you 6x. 3 times y, that gives you 3y. 3 times 3, that gives you 9. And then what you have is x plus 3y minus 2. Now, this is the first step to eliminating those. So now, which variable can I eliminate, Noah? In this case, which variable can I eliminate in this case? Which one is easier to eliminate? That's already almost gone. So if I add the first equation to the second equation, which variable is going to be automatically gone? It's going to be gone automatically. If I add the first equation to the second equation, which variable is going to be gone automatically? Noah. Hey, what's up, Javier? Noah, are you still here? Noah asked the question and went to sleep. Okay, so now if I add the first equation to the second equation, this y variable is going to be gone, because you have 3y here, -3y here, and 3y here is going to be gone. So what I have is, I add these two, 6x plus another x, that gives me 7x, either y or x, and then you can just solve for one variable and solve it. Yes. So yeah, you got it. Yeah, that's how you would do it. So 7x is equal to 9 plus 2 minus 2 is the system to solve for other variables. Okay, so you want to, I'm not sure what you're asking, Noah. So I'm not sure what you're asking. It sounds like you understand this. So what you would do is, you divide both sides by 7, and then x is equal to 1. Now you can plug this one back into any of the equation that gives you y. Okay, don't worry about it. I got it. Okay, I hope. If you don't, ask me the question in a little bit better way. I can do it for you. So yeah, this is how you would do it. Just like you said, you got it. Thanks for the help, bro. Okay, no problem. I hope I helped. So don't say thanks and you didn't get it. If you didn't get it, let me know. Okay. All right. Let me see if I have any other questions. Let me see if I have any other questions. I think I was inserting another questions. Okay. All right. So I think someone asked about limit. So f of x is equal to x to the third minus 2. So let's say if I wanted to calculate the limit as x approaches 1 of f of x, and this is the value of f of x. So and this is probably the most simple way to explain this is, limit, when you're approaching a function. So let's say this function looks like this, something like that. So if you're approaching it from the left, and this is the only way that the limit will exist. If I'm approaching the function from the left and from the right, it gives me the same value. That's when you have a limit for it. That's when you have the limit for the function. So if I'm approaching it from the left and from the right, I have the same value for it. That means the limit exists. And then you can find the limit of the function at that point. Now, it's for simple functions like this, it's simple. You just plug in the 1. Because from the left, when I'm approaching this function, it's giving me the same value from the right. And there's no, some functions when you approach them, let's say if there was an asymptote, whatever you get from the left, if there was a jump in a function, let's say you had a function that start this way, now be careful here. And then when it get here, it jumps to here at that point. So when I'm approaching the function from the left, it would be here. But when I'm approaching it from the right, it would be here. So that limit wouldn't exist. So in this case, what you would do is just replace x, 1 by x by 1. So that would be 1 to the third minus 2. This is a very, simple example, but you'd probably be better off telling me, okay, this is the limit of, this is what I want the limit of, and these are the type of example that I want, because this is pretty simple. It's basically a substitution. So 1 minus 2 is equal to -1. And that would do it for this one, for that limit. And normally it won't be that easy. I know. Let's see. All right. Jess, G24, welcome. How you doing? Hi, 39, welcome. I'm glad to see you here again. All right, cool. So, let me see if you don't know how to get rid of the exponent. Not sure what you're saying. Okay, so I'm not really sure what you're saying. I'm assuming that you have x to the third is equal to 5. If you wanted to get rid of that, you just raise both sides to 1/3 power. I'm not sure if that's what you asking. Raise this one to the 1/3. You raise this one to the 1/3. In equations, whatever you do to the left side, you do to the right side too. So things can be fair. So this one to the 1/3, it would be x to the 3/3 is equal to 1/3. 5 to the 1/3. And this is the same thing as taking the square root. So when you take the square root, when you said x squared is equal to 4, when you take the square root of both sides, what you really saying is x squared to the 1/2. The square root is to the 1/2. And then whatever, so the square root is something to the whatever that is to the 1/2. So x to the 1/2. And then they don't put they don't put the 2 here by convention, but the cubic root, they put the 3 to the 1/3, the fourth root to the 1/4. So they don't put it here by convention because the square root, that's how you write it. But and and anyway, so what I'm saying is, if you have an exponent, all you have to do is okay. So if you're raising something to an exponent, all you have to do is taking that exponent flipped upside down. So if you had x to the 2/3, raise both sides of the equation to the 3/2. So if I have, I'm not sure if that's what you're asking, I'll be honest with you. That was a very vague question. So if you have x to the 2/3 as equal to 4, raise both sides of the equation to the 3/2. So x to the 2/3 to the 3/2. So you just flip it. That's all you have to do. 4 to the 3/2. And that's how you get rid of the exponents, because this 2/3 minus 3/2 is 6/6, which is 1. So x to the first power is x. All right. Johnson, let me know if that's what you were asking. Oh, hi, 39. Good luck. I hope you do well. I hope you do well. I haven't seen you here in a while, but I know you've been you've probably been focusing on this. How you feeling about the SAT? I hope you do well on that. Yeah, any other questions, guys? Let's see. So if you have, so let's say you're solving x squared. Okay. So it's I mean it's Kendon, it's it's the same thing I was saying earlier. So let's say you have x squared plus 10 and 10 is equal to 5. This, you still solve it the same way that you would solve x plus 10 is equal to 5. But when you get to the end, you do something different because you don't have x, you have x squared. So let's say I was solving x plus 10 is equal to 5. Let's ignore this part, for example. X plus 10 is equal to 5. So what I would do, Kendon, is, take away 10 from both sides. So subtract 10 from this side, subtract 10 from this side, and then that would be what? That 10 is gone. X is equal to negative 5, right? And n is the same thing. Let's say I have x plus 3 is equal to 7, right? What I do? So all I have to do is take away 3 from both sides, take 3 away from this side, take 3 away from this side, and that means x is equal to 7 minus 3, that's 4. X is equal to 4. Now, it's the same thing if I have x squared. Let me write this in a different color, Kendon, so you understand on YouTube. X squared plus 3 is equal to 7. It's the same thing. So all I have to do is I start the same way, but the only thing that's different is when I get to the end. So I start the same way. I subtract 3 from both sides, subtract 3 from this side, subtract 3 from this side. So what's left is x squared 7 minus 3, x squared is equal to 4. Now, what do I do? X squared is equal to 4 is what I was telling you about earlier. So you take the square root of both sides to find the x. So you take the square root of this side, or the other way to say it is to raise x to the 1/2 power. Whatever you do to the left side, to make it fair, whatever you do to the left side of the equation, you got to do to the right side. So I take the square root of this side, I take the square root of that side. So x is equal to plus or minus square root of 4. X is equal to 2, plus or minus 2. Okay, so if I plug in 2 here, negative 2 squared plus 3 is equal to 7, right? Negative 3 squared is 4. 4 plus 3 is equal to 7. If I plug in 2, 2 squared 4, 4 plus 3 is equal to 7. So that's the same thing I was saying earlier. You just, whatever you do to the left side, you do to the right side. You take the square root. To get rid of the exponent, you take the, you raise the exponents to the inverse power. But I'm assuming that you're doing something simple in x squared. So you just take the square root of both sides. If you had x to the third, you take the cubic root of both sides. And that would get rid of the exponents. And I think that's what you're asking, Kenan. Does that make sense? Am I Caden? I think I messed up your name. All right, cool. I think this is all I have. I appreciate you, Caden. Yeah, okay, no problem. All right, cool. Does that make sense, Caden? I know you say yes, thanks, but does that make sense? Did I explain it to you in a way that makes sense to you? If not, let me know so I can use a different approach. Okay. Yeah, so all right, cool. I don't think I see any other questions that you guys have. If you have something that you want me to, I'm nervous because I don't know most of the stuff, but it's fine. Hi 39. I would get some sleep and relax, and just know I would say you have a chance to take it again. It's not like it's one and done. You have a chance to take it again, even if you don't do well. Just do the best you can. Right now, it's not, there's not much you can do. The only thing you can do now is stress yourself out. So I would get some sleep and chill, do something fun. And then I'm doing well, Duncan. I'm doing well. How are you, man? Yeah, do something fun. Maybe, I don't know, something fun that you can do this time, and then get your mind off of it, and then go take it tomorrow. You'll do better that way than trying to, hey D-Net, what's up? You'll do better that way than trying to memorize everything. So I think this is it, guys. I think we've been here for, is it? I think it's been an hour and a half, probably. Yeah. So it does. I just didn't know how to get rid of the x by itself. Yes. Okay, when it has exponent. Yeah, you take the square root, the cubic root, the fourth root. So there are two ways to think about it. You can say, hey, I'm taking the square root, or I'm raising it to the 1/2 power. So whichever one is easier for you. But I think you're doing something simple. Just say square root. So like for these cases, you take the square root of both sides. Whenever you get to it, and then when you take the square root, it's always going to be plus or minus, because both solutions will satisfy the equation. And to check, you can double check like I did, plug it back into the equation and see if both of them satisfy it. Colbar, I'll be going live again around 9:15 next Tuesday. And then it's live on YouTube, so you gotta follow the YouTube channel. Go on the YouTube channel and follow it, and then you'll see when it's live. This wasn't supposed to happen. I had so many questions yesterday, I didn't answer them, so I just gave you guys an extended version of the live session. Yeah. Caden, I'm glad that I was able to help. And if you guys want to see anything else, you can find one of my videos and then say, hey, can you talk about this in the live session? And then I'll make something about it. Other than that, I will see you guys another time, and I think I was able to help everyone. If you have another questions, something more specific, let me know. And oh, Nora, I'm sorry to hear that. I hope you do well, though. I hope you do well. She was struggling with the grammar part on the PSAT. I hope you do well. It looks like a lot of people were taking it too this time around yesterday. But I hope you do well. All right, guys. And I think this is it. Let me end this.